for me, for new people. Well, I think you all know by now on YouTube, which will start in a moment. Then we'll start the cohort. Great. Well, good morning, everyone. Welcome to the fourth week of the second research cohort offered by AI Saturdays Lagos. My name is Tejumade Afonja, and today we'll talk about another interesting topic. It's implementation and evaluation of a research paper. After which we'll have a round panel discussion, and depending on how much time we have left, we may do a little bit of interactive session. And I'm very, very excited to introduce our workshop speaker for today. His name is Sewade Ogun. Sewade holds a PhD in computer science from INRIA, France. He is an AI researcher in speech and language technologies with a track record of publishing at top-tier speech and language conferences. He works on research activities that is related to natural speech and language processing, including large language models, automatic speech recognition systems, and text-to-speech. He is passionate about NLP research for low resource languages and African languages. He's also a member of Masahani, a grassroots organization whose mission is to strengthen and support NLP research in African languages for Africans by Africans, and BioRAM, a global multidisciplinary research community at the intersection of healthcare and AI. Please join me in welcoming Sewade, who is welcome to start presenting after I stop sharing my screen.
Yeah, thank you very much for the introduction.
Okay. All right. So feel free to add things I did not mention.
So I'll start sharing my screen now. Okay, perfect. So I guess everyone can see my screen, right?
Yes.
Okay, great. So hello everyone. Yeah, I think a lot of introduction has been done already, so we just get right into it. So the topic is implementation and evaluation of research paper. And my name is Sewade Ogun. Well, Teju has said a lot of things, uh, so this slide might not be necessary. But of course, I also need to say that I'm also Nigerian. So, however, I currently reside in France. So I have to speak French. So that's why I also included the last line there. That, of course, je parle français. That's my Twitter link and my LinkedIn link also. So if you want to add me as a friend on those platforms, it's fine.
Where's your Twitter link? We can't see it.
Sewade Ogun. If you type Sewade Ogun on Twitter, of course, you get me on Twitter. Just at Sewade Ogun. Yeah. So I do not also know how you do it. Is it that you ask questions during the presentation, or is it possible for?
We try to take questions afterwards,
Okay.
so that we don't break the flow of the presentation, unless it's pressing.
Okay, great. So no interruption. Okay, perfect.
Yeah.
Yeah. So this presentation is going to be interesting. We're going to talk majorly on 4 different things that I've noted here. So we are going to try to identify a research question. Then afterwards, look at the feasibility of that research question. Then we also need to look at the resources we have to execute that, of course, the project, that if that gets into a project, and we also look at how to publish our findings. I will follow a system of presentation that includes a story. So I'll be telling a story while presenting. So I think so that you won't miss the story, please be attentive, all right? So that because it's going to be a long story. But when we get right into it, you understand what I'm trying to say. So, okay, so let's get right into it now. Yeah. Well, as I've not said this, but this is not exhaustive of what could have been said, but due to time limitations, I will just have to set this for objective. At least if you achieve this, then I think we've done something interesting for today. Yeah. So let me start with my first story. So Lekon was browsing on the internet and yeah, well, he got to this page that mentioned something about malaria, and on that page, he saw something very interesting about malaria. Maybe some of you do not know, but um, a lot of people die due to just malaria in Africa, or even in Nigeria, For example, here we can see an estimated 627,000 and malaria deaths just in 2020, and we have over 241 million cases worldwide in 2020, and even just in Africa, we can see that most of the cases occur in Africa. And so Lekon was really, really interested in this and said, wow, why can't this be happening in my own continent? I need to do something about it. And okay, so he said, okay, let's see what we can do about it. Then Lekon noticed that, well, most times when he observes people with malaria, they usually have a kind of face, like, for example, most of the time when you look at their eyes, maybe it's usually a little bit white or red, I don't know. Um, Also, they feel depressed, they are not usually very happy and things like that. So I'll show the other side of it. So when you look at normal people without malaria, it's like, oh, they're always smiling and the face is fresh. And Lekon said, okay, what if I can do something with this whole face thing, even just by looking at someone's face, maybe there's something interesting to get out of it. Okay, and so Lekon continued and said, okay, maybe I should do something about this. So he said, okay, I think I can really do something. And he started thinking about, okay, what to do. And Lekon noticed that, okay, with faces, that might be an interesting thing to look into. Because while Lekon browsed also on the internet, he discovered that over 93 million selfies are taken, on mobile phones each day. And it's like, okay, that's a lot of data, like people just take selfies, but they do nothing with it. So, okay, Lekon started to think, okay, should I start a startup? Should I start a company that looks into this, or I should just do it as a side project? You know. But let's go on with our story. Well, here, if we are looking at 93 million selfies, so it means on average, one person takes 450 selfies in a year, which is a lot, And we just take it to show on Instagram and, TikTok, whatever. Why people are dying of malaria in Nigeria, so and in Africa. Um, okay, so let's get into some technical details now. And so, yes, as Lekon thought about it, or thought through about it, he said, okay, so maybe we can use AI to detect malaria symptoms at an early stage. So the idea would be maybe use self-portraits to determine the likelihood of malaria. But of course, we expect that even if you detect the likelihood of malaria, you should always see an expert, like so. My presentation is not about treating malaria or, please always visit a doctor, even if you do something about my presentation, or you are passionate about malaria, I don't know, but make sure you see an expert, all right, a doctor. But the benefit of this would be that, well, if you can perform early diagnosis, then you can save lives, On the right is I just depicted something like a phone. Maybe you take a selfie and you discover that from your selfies, your phone can just tell you or give you a notification that we can trace some symptoms of malaria to one of your selfies. So we think you should visit a doctor, So something like that. Well, my assumptions for this presentation is that Lekan has done some literature review on malaria, or he has some domain knowledge on malaria and whatever, And he has also tried to look into the literature and AI techniques that can be used for this kind of thing. So, and Lekon is really, really passionate. He's passionate about this thing. So, he really wants to solve the problem. So if we satisfy this assumption, so let's dive right in. So, well, Lekon discovered that most of the symptoms, I'll list them now. One of them is that people usually have this kind of high temperature, sweats and chills, sweat on the face also. So headache, feeling confused sometimes, feeling sleepy. Well, you have to feel sick, of course. But tummy pain, diarrhea, loss of appetite, muscle pain, and yellow skin. And since we want to use selfies, so we need to trace some of these symptoms that relate to the face, that can be tracked on the face or can be seen on the face. And Silicon said, okay, maybe the only important symptoms that can really be seen on the face might be sweat, Well, people sweat. Maybe there's a form of sweat that can help you track malaria or that can help you determine malaria. I do not know. So this is not expert advice, I'm not a doctor. I'm just making some assumptions here to modulate what we want to do today. And also maybe you can look at the eyes and you say that, okay, the eyes is whiter than normal. So you say, okay, maybe this also means this might be related to malaria. And there's one other symptom that I was told when I was a kid. Sorry, that sometimes you might have a breakout on the side of the lips. I do not know if you know about this, but then I know if I have something like this breakout, people will just tell me, hey, I think you have fever, Well, I don't know how true this is, so I might need to ask a doctor. But for the purpose of this presentation, let's assume that all these things can be seen on the face. Okay, so now that you know those things that you can actually look at from a selfie, then you need to validate this your idea, right? So it means the first thing you should do is you need to go into literature. That means you read some papers to really see, has something been done about this? Well, we are not Albert Einstein, so it means there was have been precedent about some research activities in that field. So it's always a nice idea to go into literature and look at what has been done on malaria in general, on AI applications for different diseases and things like that. So it will help you to really know which direction to go in. So, and while doing that, also you really want to start small. So I mentioned low hanging fruits here because that's what it is. I know you want to really eliminate malaria totally, but start small. Just your own contribution, your own little contribution will actually go a long way. So just look for something small, interesting, and doable, and focus on it. Yeah, I depicted something small that might just include detecting facial sweat or yellow skin on the face and After doing that, then maybe you can use your mobile phone to take temperature measurements, and then combining these two data, you might be able to determine possibility of malaria. So here, Lekon decide, well, it's time to start my research and maybe to start a startup from this. Uh, okay. So the question is then, sorry, I'm having some issues with my screen. So I want to move something on my screen, so. Okay, perfect. I've been able to move it. Okay. Okay, so we've decided to focus on facial sweat. So I just want to be sure I didn't miss anything. Okay, perfect. So if we focus on just facial sweat, here we want to see, okay, or yellow skin, we want to see if we can use an AI to determine if an image is sweaty, or it depends. You might also want to use something like yellow skin. So you have an image, you want to pass it through a model, and you classify that image if it's sweaty or if it has yellow skin, whatever you decide to use. But before this, maybe you've asked a doctor, and the doctor told you, yes, it's actually possible that if a patient visits me and I look at the patient's face and I start, I see that the patient is sweating in this kind of way, um, I, I, I can fully know with maybe 60% accuracy that this person has something related to malaria. This person has fever, and so because this person has fever, then there's a high likelihood of malaria. So I'll most likely tell the person to go do some tests. And so because of that, you are really, really, confident that you can do something with selfies. But now, well, you have this validation, but where do you go from here? The first thing I want to tell you is don't just jump right in and start running models. You really want to look at baselines and try to implement these baselines. For example, maybe in one of the papers you read, support vector machines has been what they've been using, you know. And in that paper, you also discovered that they've actually done something similar to what you're trying to do, using images to determine sweaty face. So, and yes, saying, oh, maybe you do not feel motivated any longer because, well, you feel everything has been solved. So, what will be my own contribution? It's already in the research domain. So what should I do? So my next slide will talk about how to contribute to research. Even though things have been done before, you can always find where one thing to add to what is already in literature. So, and how do you contribute to research? So I divided into four angles. Yeah. So um, you can contribute in terms of data sets, in terms of trading methodology, benchmarks, and architecture. I will explain each and every one of these in detail in the next set of slides. But I just wanted to have this high-level map so that when you're looking at your own research, you can know which direction to follow. So for data sets, it's usually maybe there's no existing.
Sorry to interrupt you,
Yeah.
Sewade, but right now we're stuck on the slide that says how to detect facial sweat.
Really?
Mm-hmm.
Okay. I've been moving. Okay, so that means I've done something. Okay. Sorry about that. Okay. It's
Now
moved
it
now.
moves. Yeah.
Okay, perfect. Sorry. Thanks for calling my attention to that. So, okay, so I've mentioned baselines and I talked about support vector machines. So, as I mentioned before, maybe this is what you saw as a baseline in one of the papers you read. So, and so you also maybe you feel or you are demotivated that something has been done about it. So, because you really wanted to be the first to do this, But as I mentioned earlier, also, there's always something to contribute to research. And that's what I have on this slide. That has to do with four different aspects of research where you can make your own contributions. So let's start with data sets now. So for data sets, well, Lincoln tries to look for data sets online, and Lincoln discovered that, wow, there's no data set to use for my experiment. So what do I do? And it's like, okay, then maybe the idea would be, okay, maybe I need to start with creating my own data set. Because if I want to determine some symptoms of malaria, then, well, you need a data. Yeah, I am making an assumption that every one of you understand how machine learning works, and so you know you need a data set. So I'm not going to go deeply into machine learning here. So, but of course, if you want to train any machine learning model, you need a better data set, and you really need a very good data set, to have the best results. So, yeah, I give an example of maybe a data set you can create that includes maybe sweaty face, that has been determined to have malaria symptoms, and also maybe sweaty face that does not have malaria symptoms, and maybe normal faces. So maybe that's the kind of data set you want to create for your own project, So here, what you'll be doing is to show the usefulness of that data set, for the task. And if you can do this, I think it's a very interesting contribution. It's a very good contribution because it means you can drive research further in this line by just creating a very good data set. So the next research area might deals with your training methodology. Well, maybe as I showed you the earlier, in literature, you discover that they only use support vector machines. And so your own contribution want to be, well, support vector machines are old, they are the things of the 90s and the 80s. It's the modern deep learning era, so I want to use deep learning or whatever. And well, maybe you've discovered that, okay, maybe pre-trained models will work better, or your idea involves using generative models. So what you want to do is you want to generate faces, of people that have or generate sweaty faces. Maybe that will be one of the things you want to do. So um, using generative models, I think some of you might know about a lot of models out there now that you can just type a prompt and it will generate an image for you. So um, also multitask learning involves maybe using a single model to predict one or two things. For example, you can predict from that same image if the the face is sweaty, and also maybe if the eyes is white, something like that. Sometimes you might get better predictions through multitask learning. So also it might also be in the area of data augmentation. So you might want to show that by using real data and synthetic data, you get better results. So that might be maybe one interesting direction you have decided to take. And maybe the last direction might be the learning criteria. So you want to focus on the loss function. So you're trying to look at what is the best loss to use for this kind of idea. Looking at the loss function is usually much more um, not difficult, but you have to do a lot of work because it might involve some mathematics and some. So if you are the mathematician, and you really like proofs and things like that, the loss function might be something you might want to look at. So that's what I depicted here as learning criteria. For the architecture, your idea might be you take an existing model and you modify it for your own task. So, for example, I think every one of you might know about LSTMs, and LSTMs were modified into GRUs. GRUs are more compact versions of LSTM, so um, or transformers that were focused, or they were purposed for vision, to make what we call vision transformer. We'll come back to vision transformers later, but I'm just giving you an idea of what you can do with architectures. Yours might be you want to add a new layer to the model to make the model more robust to your own project. So things like that. Yeah. So Lekon has decided that, okay, maybe I need to work on different aspects of my project. Okay, now that Sewade has told me about this, it's time to get into work. So, or get to work. Yeah. Okay, there's a last line. Sorry, I got into my story without telling you about benchmarks. So for benchmarks, you're trying to look at comparison between different models. So it might be accuracy on different data sets. You might want to look at the training time. You might want to look at inference time, usefulness of the representation, and maybe robustness to outliers. You want to look at bias. Is the model bias to only black faces, and it doesn't really do much about maybe Asians, or doesn't do much about people of other ethnic groups. Um, so things like that, you might want to look into that. So as I said, Lekon is motivated and is really ready to dive into it. So now there's one constraint. Well, to do machine learning, you need to have resources. And in terms of resources, I mean computing resources. So uh, some projects might be easily done on maybe CPUs on your own laptop. But these days, the direction of research is towards, using multi GPUs and things like that. So you really need to consider your project and determine if it's possible for you to run it on your laptop, or you might need to get some GPUs. So I think some of you might know about Google Colab. So you can rent some GPUs, I think one or two GPUs from Google Colab. And maybe if you're also affiliated with a research lab, you might be able to get clusters, like the one I showed on the right. So, okay. And well, these are some libraries you can also look into. They help you with training your models, but I think the libraries I've shown here focus more on deep learning research. So Hugging Face, Nemo, and the Facebook FASEC. So you have a lot of models that are already implemented there, so you do not have to start from scratch. And at the bottom, I mentioned deep speed and PyTorch Lightning. So deep speed helps you to train very large models, because what it does is it shards your model on your GPUs so that you can maximize the memory. And Lightning.ai helps you to create a how do you call it? So for Lightning AI, it's really about having a template. For example, you do not need to write your training loop and validation loop and things like that. most of the work can be done for you by Lightning AI. So you might look into some of these libraries I've mentioned here. So with everything I've mentioned thus far, we can summarize and focus on one or two things. So here we know that we need a data set with labels, so we also need a model. So here maybe we think, okay, we want to focus on VITs because we can use VITs for classifying faces. And maybe since VITs has been implemented on Ogun face, so you've decided that you want to use Ogun face transformer, and you've also looked into your resources. You have one GPU on Google Colab. Maybe that's what you can afford right now. So, and well, since you have one GPU, you've also determined maybe deep speed might be an interesting thing to use, so that I can fit in my VITs model on that GPU. So just 1 second, so that I won't make the same mistake I made earlier. Okay. Okay, so let's move on. Now you've determined all this, Lekon is then trying to look at how do I evaluate my model. So this has to do with, of course, you want to make predictions, but you need to be able to determine, okay, how do I know I'm doing well on this particular task? So that's what metrics help us to do. So the first thing I would really advise is that you should use standard metrics, that is widely considered standard in literature, and only consider other metrics if you think this does not cover your own scenario. So, for example, accuracy, F1 score, recall. Yeah, I also mentioned that you should really know the why that metrics is being used in for that particular task. For example, for your task, will accuracy be the best metric to use? If your data is imbalanced, of course, you might want to look into other metrics like F1 score or recall, or UAR. And so you really need to know what metrics will best suit your project. So now you've determined the metric you want to use. Well, it's for you to decide. So I won't really talk much about that, but I think you get the high-level idea. So here you've gone into the Ogun Face Transformer and you feel, okay, I need to start running experiment on Colab. So what do I do? So the first thing you really need to know is you need to dig deep into the code and look at one or two things. For example, the first thing or one of the first things you want to look at is what is the configuration for that model, and what I mean here is there's something we call config files that are used for any experiment. I'll show you a config file soon. So a config file is usually arranged in this format. You see, sorry, this is not the config file, but this is the experimental directory. But this here and here, can you see my pointer? Okay, great. So there's usually a config file most times in the experiment directory that will help you to know where to look at. And my last point here is really to use scripts to run on experiments, especially when you want reproducibility. You want to make sure if I run this 10 times, I will get the same result. So you might need to fix some values, of course, but also use some scripts to make sure you can execute your experiment at a go. So for that script, it might look like something like run.experiment.sh. or training.py, test.py, or whatever. So when you look at experiment directories, they usually have this kind of structure. Is someone saying something? Okay. Okay. They usually have this kind of structure. So your models will be contained maybe in the directory also. So you might also want to look at that. Maybe some modules to really give you a high-level idea of what you need to do with the repository. So here you determine that, okay, I need to look at the config. And so what is a config? So, well, there's also something here, but you can always just read that. So I think I've talked about that. You should start with implemented models. So, before I go into the config, I just want to point out one or two things that you need to have at the back of your mind. I know I added this in between my slides because I really want to talk about it at the beginning. So don't automate things too quickly when you start experiments. Do not automate things. So you do not want to automate things because you want to quickly and easily catch bugs. So make sure you manually run things. You look at their output. You actually need to determine if they are doing what you really want them to do. For example, if you add an argumentation method, you really want to make sure that that argumentation method is doing what you asked it to do. All right. Then also, there's what we call garbage in, garbage out. So if you do not work on a data set, you might not get the best results you really want to get. So always make sure you put a lot of time into your data set. And due to resource constraints, you want to use a model that corresponds to your compute size. All right. So I do not expect you to use a 600 billion parameter model for 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 classifying faces, And that's because, as I mentioned before, you only have one GPU. So you cannot fit a 600 billion parameter model on one GPU. So sometimes you might need to look at what model size is feasible for my own research. So, well, even though Lekon has this nice idea, I also feel that Lekon should collaborate on this project. So it means that Lekon should bring in someone knowledgeable in the field of maybe a public health, like someone who can really give more interesting ideas on that or in that angle, because maybe Lekon is just a computer scientist and does not really know much about public health and things like that. So if you collaborate with others on projects, it broadens your mind and it helps you to really determine if your project is feasible. All right. And last thing is make sure you iterate fast. So iterating fast means that you want to quickly get results, at least initial results, to know if what you're thinking about is the best direction to take. So let's get back into config file now. So config files usually contain hyperparameters for our model. So usually key value pairs, which we use to set up our model. And as I mentioned there also, it's always good to start with the default config. So in the model directory I showed earlier, the best thing is just click the config files and try to read them and try to look at what is the default values there and maybe why are those values being used. If you start from there, it will help you and you will go far with your experiment. So a config file usually look like this. So for it, you might have some model hyperparameters that specifies the dropout ratio, activation function that's been used, training hyperparameters, dataset hyperparameters, and maybe inference hyperparameters. So I believe some of you might really know about hyperparameters, so I'm not going to really explain, or I won't go deeply into that, but most experiments these days usually have something similar to what I've depicted on the right here. So, and your config file might be stored maybe in a JSON file or in XML or in a data class, but it globally they usually have this kind of key value pairs that can help you to determine the default values for that model, so or for that experiment. So so for now you've looked into a config file and you determine, okay, well, I need to start from there. Okay, so the first thing is you want to really run that baseline using that config file and make sure you get the same results that's been reported in the literature you read or something, or in the paper you read. So start with the default values. Then afterwards, you want to determine what works better for your experiment. I mentioned here better because sometimes it's difficult to determine what works best, because it might require extensive hyperparameter tuning. And most times, better is usually okay, especially in the initial stages. As I told you, you want to iterate fast, all right? Then also, you want to adapt them to your own constraints. For example, if the config mentioned 4 GPUs, you only have 1 GPU, right? So it means in the config file, you need to change the total number of GPUs to 1, because that is what satisfies your own constraint. So maybe in the config file, the batch size that was used there was 22048. So they used 2048 as their batch size. But in your own case, you only have 1 GPU and your batch size cannot be more than 16, because you cannot fit 2048 training examples on your own GPU. So you really need to look into the config and really adapt it to meet your own resource constraints. So yeah, also you want to test one hyperparameter at a time to make sure you really know how that hyperparameter affects your experiment. And also, do not waste too much time on hyperparameter search or hyperparameter tuning. And why I'm saying that is that you can do more extensive work on hyperparameters in your ablations, all right, in your ablation studies. So that's why I really want to give this advice. Just make sure you determine what works better and you go with that. All right. Yeah. So an example here is you want to balance model size with batch size with number of GPUs. So, well, maybe the maximum number of parameters you can fit on your own model on your own cluster is 200 million parameters. So you might need to balance that with batch size. So what's the batch size that GPU can take at a go? And you also need to balance that also with the total number of GPUs you have. Yeah, I'm using 4 GPUs as an example, because if you have 4 GPUs, then you can run larger batch sizes. For example, here with 4 GPUs, you can run with a batch size of, I think, 64, because, well, some of you are knowledgeable about deep learning, so you know what parallel computing is all about. So with parallel computing, you can run larger models, with larger batch sizes on your GPUs, and you can also do um, model parallel training. That means you can shard your model on different GPUs to maximize the memory capacity of your GPU. So for your own example, for your own research project, you might also have other constraints. But I just use this as an example because it's something you need to consider initially. What's the maximum batch size that can fit on my GPU? What's the model size that I can use for my experiment? Then versus the total number of GPUs I have. So So Lekon has determined that, okay, now, well, I have one GPU, I can fit a 200 million parameter model and on my, and I can also use 16 batch size. So, well, we know all this now, but we really need to run the experiments now. So here I'll be talking about how do you really look at your experiments and how should you run your experiment. So here I have said that you should structure your experiment in such a way that it tells a story. So I want to be able to look at your tables and interpret your tables in a clear format, by just looking at your table, I can make a lot of inference, I can really determine if your model is doing better than your baseline. So that's why I have a table like this. For example, with this table, if you have your baselines on the left like this and you have different metrics, if I look at this table with the baselines on top, I can really determine if your own model does better than your baseline, and how I can also compare maybe a large model with a small model compared to other baselines. So when you have tables like this that can quickly really give you information about your experiments, it's usually nice. So for example, I'll give you an example on the next page of VITs. If you look at in the VITs paper, there was a table that was presented like this. And from this table, I can quickly infer on the left that these are all the data sets that were used, for the experiment. At the top, I can quickly see that, okay, these are the models, and with these hours, I know, okay, hours are their own models. That's the model they are proposing. And these two here are somewhat baselines for them. So here, it's really nicely presented. Also, you can see that there's a form of confidence interval. I'm not sure if these are confidence intervals or standard deviations, one of the two. But here, you can also see that they also give this kind of confidence intervals because they perform the experiment multiple times. So by performing the experiment multiple times, they are determining that the result they got is not due to chance, not due to their GPU. Maybe the GPU just gave a better optimization on one run than other runs. So this helps to show that. Also, lastly, you also see that on the right-hand side, there's a star. So sometimes you might not really need to run these baselines if you feel the baseline has also performed the experiment on your own data set. Well, I would say that it's a good idea to implement the baseline, run it, and get the same result. But well, depending on your own constraints, sometimes you might just want to report what has been reported in another paper. So sometimes you might see something like star. And that's what I've highlighted here, that sometimes in some papers you see that they just report some result as it is. But I also want to mention that when results are reported from other papers, you need to take those values with a grain of salt, because the results might have been due to some of their own constraints. For example, maybe their own model was they did the experiment using uh, um, um, 256 GPUs, and you are only able to run your own model on one GPU. So sometimes your GPU capacity, your learning rate, your batch size, some of these things might significantly affect your own results. All right. So that's why I still mentioned that it's a good idea to run that experiment on using your own constraints, if possible. But if it's not possible, and if you cannot do that experiment, then maybe you just have to report whatever they reported in their own paper. So I also talk about qualitative analysis. Now you have finished your experiment, and one thing is you really need to do some analysis. Okay, why is my model behaving the way it's behaving? So from it, you can see some attention maps on the left, and here you can also see that they are trying to show us what the model is using, filters that the model is using to make predictions. So this is what I call qualitative analysis. It's always interesting to have this kind of analysis in papers. It gives us intuition about how tells us intuitively what the model is looking at. So finally, you have all this, you've done analysis, you need to do some ablation studies. So ablation studies helps us to determine if your results are not due to chance or it's not by chance. And if maybe we also want to determine if there's really a significant improvement over other models, or it's not just due to hyperparameter tuning. So here you can use two different methods. So you can take a base model and in turn, in one part, add a proposed maybe loss function, look at the results, then maybe in another part, add maybe a proposed hidden dimension, then maybe in another part, add a new augmentation method. So this is one direction you can take. So this direction involves adding your new ideas to a base model to really see the effect of each of the things you are proposing. Or you can take another route that goes the other way. So it means you take your final model and you remove different parts of the model. For example, you might want to remove the proposed loss and replace it with the original loss in your baseline. You might want to remove your own proposed hidden dimensions and you replace it with the original baseline, or you might want to remove your own proposed augmentation method and replace it with the original. So I think you get the idea, right? So it's either you do additions or you do subtractions. Both works for ablation studies. Ablation studies can also be done in other ways. I'm not saying this is the only way, but I feel this is basic enough for people to understand. So if you start with this, I think it's really nice, and it gives you an idea of what and where the improvement in your model comes from. So finally, for the last 5 minutes, I want to talk about now you've done your ablation studies, you have results, and now you need to really publish your findings, and so you need to write the article. So research paper usually have this kind of breakdown. You have the title, you have the abstract, introduction, literature review, and whatnot, methodology, experiments, result, and discussion. Here, I'll focus mostly on the introduction because that's where you really want to convince the reader that it's worth their time, that the research you've done is worth their time. So if I pick up a paper and I read the introduction and I do not really get the idea in the introduction, I do not really understand what the paper is trying to say, I'm not sure I want to keep reading that paper. So it means your introduction carries a lot of weight. So humans are emotional beings, so it means your introduction must really, 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 catch the attention of the reader. The same way I've done in my presentation, you see that I started with a problem and I walked you through my presentation. So you really want to walk people through your introduction in that same way, So you want to start with a global perspective and come and then focus on details, technical details in your introduction. So for example, you want to start with the motivation. How does this paper connect with the world? You can start with, in our age, 95% of deaths from malaria comes from Africa. And, because of that, we think we need to do something about it, I don't know, but you just tell a story, the same way I've told a story in my presentation. So then after the motivation, then you go into the problem statement itself, So you want to say, what is the particular problem you want to solve? Yes, we know that malaria, people in Africa have malaria, okay, but what's the particular problem here now? Okay, so research-wise, you want to say that here, your problem statement would be something related to determining, if or determine at an early stage if someone has malaria or not, so that the malaria can be treated early. So that's a focused or particular problem statement, So, and then you also tell us what is the status quo. So in the status quo, you are trying to tell us that currently there's no cheap method or to determine um, there's no cheap method to really determine if a person has malaria. So you are proposing an AI model or an AI algorithm that runs on phone using selfies to quickly check if the person has symptoms of malaria, so that then next steps can be carried on. So you are telling us the status quo. You're also trying to tell us what has been done about it in literature. So maybe one or two persons have looked into this too. That you also need to tell us. Then here, in the contributions, you want to focus on what you have done about this same problem. So here, you want to tell us, well, I am proposing that we use this particular approach. Then you tell us maybe, with using this particular approach, we can cut down from 90% to 60%, At least if your approach gets to 60% out of 90%, I think it's a good idea, So here, in general, you just want to be coherent. You want to follow that story. Make sure you also eliminate grammatical errors, because sometimes you might have a good story that's coherent, but it's difficult to read. So finally, maybe before finally, your methodology and experiments, you also need to include them, but they are easier to write if you follow my presentation, because here you have qualitative analysis, you have your results, you have your experiments, so you can just describe all these things easily in your experiment. So in conclusion, research is really more meaningful if you start with a problem and then find a solution than the other way around. So it's not that you pick up VIT and you start thinking, what can I do with this model architecture? What can I do with this model? No, that's not how to do research, You really want to start with a problem, then propose a solution. You want to think about the resources you have, your data set, existing literature. Also, you need to know that publishing your work requires that you write it in a language that its readers will understand. So, and that's what I try to explain in the previous slides. And finally, I want to say that you should enjoy the process of research. While doing it, enjoy it and really and learn from it. All right. So thank you very much for having me. Yeah, I added a picture here that shows me some years back wearing my AI Saturday shirt, so yeah, so I'm also part of AI Saturdays. And this was one of the shirts I also bought, I think, some years back. So yeah, so thank you very much. Then we can go into questions. Yeah.
Oh my God, thank you. This is so surprising. I didn't know you have this shirt. Oh my God,
Yeah,
I'm going to wear it next week. Wow. Well, thank you for
I
buying
also
this
have it.
shirt.
I also have the shirt.
Really?
Well,
Wow.
what a nice surprise. Then we can all wear it
Yeah.
next week if you're
Yes.
attending.
Yes.
Okay. Thanks a lot, Sewade, for your presentation. I think you really tried to pack in a lot of germs in the story. And, I'm just like thinking about how you're working through the research process from getting the idea to now thinking about the baseline methods, the metrics to choose, and so on. And I hope that everyone here also have learned something from that process. And of course, like this is just the beginning of like this particular journey that you're onto. So I'm hoping to questions now for Sewade. We can take one or two questions from the audience if there's any pressing questions.
Yes, I have two questions.
Okay. Please go
Sewade,
ahead.
bonjour. Je parle très bien
Hello,
français.
yeah, bonjour.
On a été dans la même classe à AI6.
Ah,
We're in same
vraiment?
section, yes, 2019. I have the shirt.
Okay, cool.
Yes, I was that lecturer coming around, taking classes from Teju and all that. Teju has been phenomenal. God bless you,
Yeah.
Teju. Yeah, my question.
Yeah.
Two questions.
Mhm.
There is a slide you showed before the ablation studies.
So,
What are
sorry,
you
I'm
saying?
disconnected. I think
Ablation studies, there is a slide, the very slide before it. You talked about colors by the right. What were you saying about the colors? There were objects by the left, and by the right, there were shades of colors, different shade. I don't know what you were trying to explain there. And then on the
let me
ablation,
go back to
yes,
that page. So,
yes,
is it this?
yes.
Ah, okay. So
These
in this,
RGB embedding filters, input, attention. What were you saying about this page?
okay, so on the left, I think if you know about convolutional neural
Neural
networks,
network,
I think
yes, I do.
filters like these came from convolutional neural
Okay,
networks, and these are
okay.
looking at the filter maps. They look at filters. That's um, the filters used in these networks, and each of these filters might focus on one or two things in the image. For
Okay,
example, some of
okay,
these filters might
okay,
correspond to detecting edges.
okay,
Some
okay,
of
okay,
them,
okay, okay. Oh, okay, okay.
yeah,
Is
some
that
of them
what you
might
were trying
correspond
to
to
see?
detecting,
The pooling layer, the max, all those layers before the final
yes,
output.
exactly. Some of these
Okay,
filters, yeah, are usually purposed for different things, especially at the
okay.
early stages of your layers. You discover that these filters usually
Hmm.
focus on one aspect of the image, you
Okay,
know.
I understand. I've got what you mean. Then look at this input attention. What do you mean by input attention? What are you saying? Look at the input attention. There are two different things from the left. What are you saying here, please?
Yeah, okay, good. So attention, I think this attention really depicts where the model is focusing on to
Ah,
make its
okay, okay.
prediction. So, for example, you give it an image like this,
Mm,
and this attention
mm,
shows where the model focused on to make the precision and say, oh, this is a dog. So,
mm,
it's the same way for human beings. When you look at images,
mm,
you focus on one part of the image at a time, and you
okay.
make inference about that image. So this is just showing us while the model is making its prediction, what it focuses on. So I think
Okay.
I've answered the question, right?
Okay. So the one,
Thank
the picture inside by the attention column is what it is focusing on. Yes,
So
that
yes.
picture. Like
okay,
the
yeah.
this is
So the
it.
picture, no. So there's a way you recover
There's a
attention
black
maps.
background, there's
It's
a black
another thing
background, and there's a
entirely.
picture. Is it the picture inside it is focusing on, not the black background?
Ah, yes. So it's not the black background it's focusing on. It's what is inside, the white
Inside.
part
Okay.
that's inside.
Okay. All right. Good.
So it's
Then the next
focusing
slide.
on this dog, yeah.
Okay. All
So,
right.
Not
I've
the
got
black
it.
sorry,
background. The black
Dr.
background are black
Simitu.
because it did not focus on that side.
Okay. Please.
Sorry, Dr.
The next
Simitu.
slide. I will
Sorry, excuse
please,
me.
Teju. The next slide.
Sorry.
Add and
Sorry.
remove loss function. What were you saying? This next slide on this ablation. Next page, please. Yes. What were you saying? Add, remove. What were you saying here, please?
Ah, okay. So in this part of the distance, so here I was talking about I think I mentioned your proposition is that you want to use a new loss function, for your new experiment. Maybe, for example, normally they were using cost entropy loss, and you've decided, no, I want to use a contrastive loss. I know I might be saying something high level, and that's because I'm assuming that you know or you have a background in deep learning.
I know, I understand.
So that's
what
why.
I'm saying is
maybe
it this or
contrastive loss.
this?
So you want to
Are we
compare
to choose one, this or
cost
this?
entropy to contrastive loss,
Okay, what I'm saying is
Dr. Simito, I'm really sorry. I would politely ask you to please take the rest of the questions onto the chat.
Okay.
So, and allow Olusegun to ask one question, then we'll go into a break, and then we can do another QA. Thank you so much for being very engaging and passionate about this topic, but we are running out of time right now. Thank you. Segun, can you please ask your question? Then we'll go into a break.
Okay. Thank you very much. Thank you for the presentation, Sewade. Okay, so my question is actually somehow basic. You mentioned it during your presentation that if you get an idea of a problem to solve, but you don't have a data set available, so you can curate a data set. So I just wanted to probably suggest some idea of how one can possibly create a data set for a project that probably don't have data set available to solve. So that would be my question. Thank you.
Yeah, so I need to ask you a final question. So creating a data set will depend on what the idea is, right? So as I mentioned, there is an example of faces, So for example, if your idea is about determining facial sweat, so it means that you really need to get images of faces and whatnot. Now, also, I didn't want to go into details because, firstly, if you want to do this, you really need to consider some ethical. There are some ethical things you also need to consider. Firstly, you need to make sure you get you need to get the go from the people you get these images from, because it means I do not know the word to use here now, but what I mean is ethically, can you use images of people? So it means each and every one of them have to maybe agree to give you their own images, for research purposes or whatever, So it means you really need to make sure that each and every one of them agree to this. Also, another thing you might need to do is start small. You might need to create a very small data set and make sure it's possible, or this particular set of data sets you've used, can work for that particular purpose. Then from there, you can then look at how to scale it up from the small data set you have. So these are things you can do. Another thing you might need to look into is how do you, in what format do you want to collect these data sets? So that's another thing you need to look at. So, for example, for images, of course, we mostly use RGBs, but for others, it might be, for example, if you're looking into medical domain, it might be X-ray scans, and so there are different formats for also collecting data sets. So all this you need to
we really need to
consider.
wrap this up. Thank you so much. We really need to wrap this up. We still have you for the next 30-45 minutes, so we can come back to some of these questions. I'm so sorry, everyone. It's just like we're running a lot behind. So can you please give Sewade another round of applause? And I will start sharing my screen for the next session. Thank you so much, Sewade.
You're welcome.
Are you able to stop? I can also do that. Then I'll share my screen, and then we can just literally my next screen is that please take some time off. We've been sitting here for like more than an hour now, so I would like everyone to take 2 minutes to stretch and maybe get some water and use also the time to fill the attendance form. And in by 11, like it's 11, right? Like from my side, 11:15, we will start the panel discussion. Thank you to all of our panelists that they're already here, and I'm sorry that we started a bit late. So let's come back 11:15. I know that's like 3 minutes break for the panel discussion. Welcome back, everyone. I hope you had a nice stretch. And right about now, we'll come to the panel discussion session. I'd like to ask you to please scan this QR code so that you can ask your questions live. The panel discussion is scheduled for 30 minutes. I've prepared some questions for our panelists, but we also would set aside about 10 minutes for audience questions. So depending on where we're at regarding time, maybe we would close today's sessions with this panel discussion. And without further ado, I am delighted to be the moderator today for amazing speakers, panelists, my friends. My name, as you know, is Tejumade Afonja. I'm the co-founder of AI Saturdays Lagos, and I'm a doctoral researcher at CISPA, Cohort Center for Information Security. We have Olumide Okubadejo, Sahar, Abdelnabi, and Sewade Ogun. And I want to especially introduce them by reading out their bio because they're fantastic humans. So Olumide is a technology leader with 15 plus years of experience in the industry. He holds a PhD in AI image processing from Université Grenoble, Alps, and a master's in artificial intelligence from the University of Southampton. As head of product and AI at Sabi in Lagos, Olumide leads the development of innovative products across all business verticals in multiple countries. He's also an adjunct professor at ESIEE Paris, teaching AI and data science for business decisions. His past roles include work at Audionomics, Sony, Spotify, Google, and others. He speaks English, French, Hausa, Yoruba, and some Italian. Buongiorno. Olumide, I know you're on the call, but if you can have your camera on and we can see you, that would be great.
Hi.
A quick hello.
Hi everyone.
Nice to see you
Lovely to be
again.
here.
It's been so long. Nice to see you.
More than a year now.
Okay. Next, I'd like to introduce my dear friend Sahar. Sahar is an AI security researcher at Microsoft Security Response Center. Previously, Sahar was a candidate. I mean, she's done with her PhD now, just waiting to different. Was a candidate at CISPA Helmut Center for Information Security and obtained her master's at Sahar University. She is interested in the broad intersection of machine learning with security, safety, and socio-political aspects. This includes the following areas. One, how to understand understand these models, probing the models and mitigating the failure modes of machine learning models, their biases and their misuse scenarios. Two, how machine learning models could amplify or help counter existing societal and safety problems like misinformation, stereotypes, and so on. And three, how emergent safety challenges posed by new foundations and large language models can be better understood. So without further ado, I'd also like Sahar to say a quick hello to our audience. I see you on the call.
Yes,
But
hi,
now,
thank you.
yay.
Thank you so much for having me.
Okay. Thank you for joining, Sahar. And you already know Sewade has been with us for more than an hour now. And so please scan the QR code without further delay. Let's just get right into it. So my first question is, how do you decide when an experiment or some findings you have is significant enough to be published? You've been working on this malaria problem for so long. So how do you know that now it's something you want to show the world or the world should care about? So I'm going to start with Sahar. These questions with you, if you have would like to share some thoughts.
Yeah, sure. Actually, I would like to hear from everybody. I realized when you share the questions, they are so great questions. Okay, so I want to know everybody's answers to them because I think I may have some thoughts, but it's really hard to actually, or at least for me, to translate actually what you do, like how to write a paper, translate it to actually sort of a structured way. Sometimes you just do things because you feel like this is the right thing to do, but it's hard to it's a good exercise actually to remind yourself, okay, I need to do this because of 1, 2, 3. But yeah, so actually, do you mean an experiment or do you mean like a whole research idea or a project?
Like a project. You started with a project and it's like, oh yeah, how do you know that what you have is enough to start writing up a paper or would be enough to get into a conference or something like that?
Yeah. Well, I think if it's sort of tells us something new that we didn't know, I usually think of starting research projects with if there is something that you would like to share about, well, there is an area that people didn't look into, or a new sort of application or a new risk, like because I work on like safety or something that you think might be very relevant in the future, but people have been overlooking it or sort of researching something else for the majority. For sort of like how to know if it's significant enough to like in a good state to be shared. I think if it has enough coverage of like a whole story, if you can like sort of, I know you're a very good storyteller, Tiju. So if it's like sort of when you write a paper, if you write a paper and then like when you write the whole introduction and then you feel like, well, if you can cover the whole story of the basic questions that people will ask is like, okay, so why do I care? Why is it better? Why should people work on this next? Because I think that's like sort of question important. Usually when you write papers, like not only what you have done is that, well, is it going to advance the field? If I'm interested in the field, what else could be done with it? What are the future extensions? Something like that. If sort of like you have enough to write an introduction that would sort of make people when they read it want to continue reading the paper, but because sometimes unfortunately like with reviewers and maybe other people reading the paper, sometimes they would actually read the introduction as like, okay, I got everything that I want to know about it from the introduction, and maybe they would jump to conclusions. It's like, okay, so this work is not complete because it hasn't done 1, 2, 3. So if you have all the basic experiments that would sort of, when you write an introduction, would answer these basic questions of like, why is it better? Why do I care? What's the problem? What are the extensions? Then I think that would be significant enough to write and get it published at this date. Of course, there is no enough. And sometimes like I tend to just like feel like, okay, that's enough, I need to do something else or I need to work on it, but I think at least that would be like the threshold sort of.
Thanks a lot. I think you nailed it right there. It's like research is never ending, right? There's always something to do. You can always improve, you can always add more, but at some point you just get a pull the pros, like, okay, I have a set of assumptions, I have a set of questions, and I have been able to like validate those questions and to sufficient detail, and then now I want to write it up and publish these findings. Like, thanks. I think you summarized this really well. Olumide, would you like to add something to that?
So I think one of the interesting things for me is because I get to wear two different hats at different times. The research hats within a university and also research within industry, and they're quite different. The choice to publish is hinged on different factors, depending on where you are.
So
because
you're not
it's
a businessman.
I still teach. I still teach. And so what I was trying to go at was, if like in industry, because it's something new doesn't mean you can publish. There's a lot of bottlenecks that you have to get through. You have to go into meetings with legal and make sure that you have the right patents, make sure that the company is protected and can make money from it. But if we go back to university research, which I still engage in, the way that I see it is there's two ways, right? And one way is really overemphasized. The first way is you have done the research, you have gotten in results that you consider interesting, that maybe have pushed the boundaries positively in some area. It might be the introduction of 2 or 3 parameters. It might be that I give an example. Maybe you have a parametric model, and it wasn't accounting for all the unique situations that it was being used in, and you found that, you know, there were relationships that were not being captured in your current parametric model. You found those relationships, introduced them. That might be something. It might shift it by maybe just 1%, but the fact that you're able to capture those new relationships and push to more edge cases might just be something that, you know, is worth saying, hey, we used to think that the functional relationship was just based on 2 parameters, but right now I found that there are 4 parameters. These two just, you know, come up in different edge cases. It's just like the Newton-Einstein thing, you know, and Newton came up and said, these are the 3 laws of I think motion, and Einstein is like, yeah, it works here, but you know, when you introduce, you know, different gravity constants, when you introduce multiple things, it doesn't work as much as you think it should work outside of here. And then when you go to macroscopic and microscopic levels. But yeah, you get the gist. Something interesting, something good, you know, 1% more parameters, you publish. But the one thing that I started to do a lot of negative right now is, right, a lot of times as researchers, 90% of what we do does not work. It doesn't. Yeah, like you're banging at your computer, you are so sad, you want to smash it. You know, it just doesn't work, right? And a lot of times, you know, you just you just throw it away and you only report on the things that work. And lately, I try as much, and of course, not many conferences just want to collect a paper that is just based on failures. Sometimes I just decide to publish it in the community or whatever. Just put it out there. Hey guys, I tried for a year and I failed for the entire year, not one success. It's worth publishing. It's worth putting that out. And I think there's times where, you know, if significant success, you know, more parameters, more functional relationship, new ways of doing things as also critical. The new way of doing things might not necessarily surpass the old way of doing things, but it has a longer lifespan. When attention models came in, they didn't necessarily scale to the convolutional systems that we had in those days. You know, they were still the best, but attention models right now, you already have, you know, mixed with convolutions are doing way better than your typical end-to-end convolution models. So these are things that you need to put into perspective when you decide that, you know, you want to publish.
Thanks for that answer. I think it's like thinking about the field, also thinking about the direction it's moving, and you know, just experimenting and researching and trying out ideas, and so many of that. And to talk about negative results, I have some questions about that as well. Well, maybe we'll come to it. But before then, Sewade, I just want to give you also an opportunity to jump on this if you have something to say.
You both nailed it, so I do not really need to add to it. Thank you.
Okay, so another question, maybe somebody can take this, is like, how do you determine which baseline to include in your paper? What criteria makes a baseline fair, in your opinion?
Okay, so well, the truth is, firstly, as I mentioned,
I think we lost Sewade to technical problems. But if anyone of you, Sewade, can you hear me?
yeah.
Okay, it's better now. Sorry, I was about to open up the question to the rest of the panelists, but please go ahead.
Okay, so
we can hear you now.
okay. So now the thing is, you've read some papers, you've done your literature review, and you know there's existing literature on that particular project or that particular topic. So the first thing to do is to start from there, you know, and to examine what are the things that have been done, what is the state of the art. So your baseline should most likely be state of the art in that area. So, for example, if your model is talking about vision transformers, you know, I would expect you should also include something that has to do with maybe convolutional neural networks because they were previous state of the art, or sometimes even some convolutional neural networks perform better than vision transformers. So you want to use state of the art models as your baseline. You do not want to use very archaic models or models that are very old that you know that they're surely not being used nowadays. You understand? So those are the kind of baselines you want to use because they are fair. That's where the research is right now, and that's what you want to improve on. So it's easy for the readers to also know that you've actually significantly improved on the existing literature. Yeah.
So you like your definition of fair in this context would be like how recent is the like what you're comparing to, you know. But I have a question. So what if like there is a baseline which was state of the art maybe 2-3 years ago, but really this was what shaped the field, and the rest of the new models that are being built on top of it, which is like some cherry on top of the cake that may change, but you know, in the paper, everyone claims state of the art, right? So which one should you be comparing to? Should you focus on this, the model that really shaped the direction of the field, or you know, you need to choose the recent 2024 paper that that just came up? How would you decide?
Okay, so sometimes it's really about your constraints, you know. Reviewers like that you compare with the current state of the art because they really want to determine what is the shift, what is the difference between your own current result and what existed, you know. So for reviewers, if you do not do it, they will surely ask a question about it. It will be in your in the comment section, and they will ask you, oh, okay, why didn't you compare with this model? But the truth is, you should also know that maybe you did not start your research today. You started maybe your experiment some months ago, and maybe at that time, some of these models didn't even exist, you know, because as we know, in AI, everything moves very fast. So it might still be fair enough to continue with your own research and not focus on the new models and just give an explanation telling us, well, even though there are new models, but the changes to the models do not really imply that you change your baselines. You can also give us that kind of an explanation, and which is fair enough. Also, you should know that you cannot also compare with all baselines or all state-of-the-art models. So you have your own constraints too, resource constraints. So it might be fair to just focus on what you're currently using, as you mentioned. It's also fair if you can really give us an explanation why you did that.
Thank you. So Sahar, Olumide, do you have something to add towards that? Sahar, maybe.
Yes, I agree with that. About like, is it state of the art or not? I think regarding your question of like, which state of the art, I think to try to unify some sort of like the other confounders or the other factors, or maybe the sort of the setup of your method to previous methods, for example, like, or at least make it clear in the comparison. For example, if you have a model that 7 billion model, and then you compare to a GPT-4 LLM or something, that's significantly larger. You can include this comparison in order to show like what is the gap, but of course no one would expect that you would have the same, but it's just like to have like sort of upper lower bound or something. And then what could be in order to show actually how, or to study how much you contribute with, for example, the new method, you can compare to something that has comparable setup, like with the same size, for example, and then which will be, I guess, a little bit similar to what you said, is that you compare to the original method, and then you assume that since you compare to the original method, for example, case of transformers, and then like you improve over it, maybe if you scale it up, similar to what happened, because I think when you sort of, it depends on the application. If you are sort of proposing a very new architecture, no one would expect that you would actually scale this new architecture from it should be like that, but you would scale it from the first paper you write. You will because there are, for example, some work now that's been proposing alternatives to transformers, for example. But then in this case, if you are having a proof of concept, for example, a smaller proof of concept, then in the setup, it makes sense that you don't compare to the state of the art in the area that has been there for like 7 years, but maybe to something that's a little bit comparable to your setup in order to start from there. Yeah, I think unifying the setup is something that I wanted to say.
Yeah, thanks a lot, Sahar. Olumide, you want to add something to this?
Yeah. I say it's it's a very complex question, and I know that they've done quite some justice to it. Knowing which is the baseline can actually affect how people perceive your paper. I do have internal the way that I think about it when I want to know how to propose a baseline for my paper. And I think that I talked about if I'm looking at structural changes, maybe to a paper, if I'm publishing an attention is all you need, for example, it's more of a philosophical paper that is proposing a new method of doing things as opposed to something that is particular to one field, right? It must have been tested on multiple fields, but what that paper was actually saying, and that's one of the reasons is the basis for all the advancements that we have in AI, I know after 2020, is that it's a philosophical way of doing things. It's saying, hey, this is how we can do attention mechanisms and stuff like that. When it comes to that, I might not necessarily have to publish or have a baseline that is the last model that improved something on one particular task. Because for such a model, because you want to tell people that this is a better method of doing things, in fact, you will be showing results in multiple fronts. You might say on this task, on that task, on that task. If you have to look at all the baselines for each particular task, it might become cumbersome. So, and also because you might miss it. So what I typically do is I would look at the last accepted, public baseline for maybe each of those individual tasks or structurally as a method of doing things. But one of the things I just really want to touch on is, in effect, when you then choose your baseline, because researchers, and I think we've made this joke a lot, Teju, how researchers are the worst programmers ever. Researchers would actually give you code that you cannot actually reproduce anything, right? I saw a researcher's code where one function was actually returned true, and I'm like, geez, this doesn't make any sense. Uh, and so because you have that, sometimes you have to rewrite the code, you have to write it and you have to then generate the baseline. Sometimes there's a lot of randomness that comes into reproducing these baselines. They don't tell you the seed, nothing. And so it's essential to be fair, and fair is a lot of work here. A paper says we did this is amazing, then you're trying on your own, you're not seeing something nearly as good, and then you have to try multiple seeds, right? You try because they just refuse to tell you the seed that they use for their random functions. So in as much as, yes, you do have to choose the paper, sometimes you then have to replicate the paper because there's no acceptable code out there. Or maybe the code out there is something that, people have heavily engineered, because we have to make a difference between engineered code and actual research code. And you really want to be fair in that sense. So you want to get back to the research code, and that means you have to implement it yourself, and then you have to try different parameters because sometimes they're just vague. This is what it means to be fair. Unfortunately, because of the way that researchers we are, it might mean a lot of work for you. But in that sense, when you get to that point, also do not hesitate to reach out to the researcher. If you can have a conversation and say, hey, you didn't put your seed. I want to know, did you have a specific seed or you were just randomizing every time you did it? Yeah.
Thanks a lot. Oh, you nailed so many points right there, Olumide. So let's quickly take the question from the audience on Slido. It says, do you design models from scratch for a project, or there are libraries for models already made that you can just import and make use of? Anyone can jump on that question. Or would you like me to read it again?
I could jump on it.
Okay.
If I could start. So there's two ways. When I'm an engineer, I just import. When I'm a researcher, sometimes I import. A lot of times I import, but I do go through the code to make sure that it's the right implementation. Researchers are control freaks. So a lot of times when I wear the hat of a researcher, I automatically become a control freak. I really want to know that that particular layer is functioning as it should. A lot of times also as a researcher, because you're pushing the boundaries of things, some of the models that you're going to be proposing, would not be, it might be as simple as a different initialization strategy, but that completely changes how so it's either you're creating and using as a plug and play, or you have to write the model on its own. There was a time where we could only work with static graphs, and it's just once you have a static graph, that's it. Now we can work extensively with dynamic graphs, and that is why you have all this recurrence. And I think that was when ResNets became really big. But a lot of times as a researcher, you're proposing, especially when you're proposing maybe a new model or a new way of doing things. A lot of times, sometimes it doesn't exist. But in the end, I would always say it's a mix of both. Like for whatever doesn't change within your model architecture, that's my own rule of thumb, but I would use a library as opposed to rewriting from scratch. And for what changes, I would then write it so that I can have fine-grained control over it. Some of these things, I still plug them back into existing infrastructure. For instance, in as much as I might be writing maybe a TensorFlow layer by myself, I still want to plug it into the Tflow system so that, I can just deploy it on some cloud and then, the pipeline just runs. So it's always going to be a mix of both.
Thank you. Anyone else wants to add to what Olumide said? Okay.
So yeah, just want to add something that so if you're looking at recent research, especially large language models, you discover that most of the time you need to start from an existing library using an existing model, because sometimes these models have become very large. So, and you need to make use of pre-trained models. So for that kind of research, you surely want to start with an existing library. For example, Ogun Transformers library or FSEC or whatever you are, because it will be a pain for you to say you want to implement that same research from that same paper from scratch. So, so it depends on the kind of experiment you're doing, and that determines which direction you want to take. So, just to mention that.
Okay. Thanks, Sewade. Sahar, would you like to add to this?
Yeah, I agree, because I think my line of research is similar. Is that usually it's for me when working on LLMs, it's hard to first almost impossible to train it by yourself, and also hard to implement everything by yourself. But so depends also on the application. Like something you would start with a Hugging Face library, and then if you want the output to be in a specific way, or if you want to like do some internal surgery of the model, like instead of taking the output, you are trying to inspect something else internally, or maybe you want to train on something else, and then you want to change the training or the loss to match your application. So for me, it's usually always starting with a backbone of an implemented model, and then depending on the research project, adapting it to some extent.
Okay, thanks a lot, Sahar. So, audience, please, if you have any question, put it in Slido, and I'll take them simultaneously. In the absence of audience question, we have a question that I've prepared for you. And the question is not easy to answer, I agree, but it's just like just getting your feel about this. What if you have a poor performance in a different setting, like from a paper that you read, and you try it out, you implement it, but there's like it's not working the way they said it was working. Does that invalidate the contribution that they like the claims that in that paper? Why and why not? I like to start with Olumide.
Oh, interesting. Wow. So yeah, there's a philosophical way to answer this, right? I try as much as possible to be as philosophical as possible. Although I know that in the real world, I remember during my PhD, if that happened to me, I'll just feel like, can you just work? And let me be done with this thing. But this is how I see it, right? We cannot underestimate the work that we're doing as researchers. As researchers, we're trying to approximate, because everything we're doing is approximations. We're trying to approximate explanations to certain underlying, relationships that we cannot actually parametrically capture. Even when we do have models that try to capture the entire parametric support of the entire problem you're trying to solve, it's either even if it captures it, sometimes we can't even explain it. Right. So the model is working. Can you explain how it is working? No, but I just know it works. So because of the complexity of what we do, a lot of times when I get to that particular scenario where, in some set of conditions it works, and then maybe in some set of conditions I wake up, the proverbial, oh, it works on my computer, it doesn't work on your computer kind of stuff. I mean, after screaming at my computer for like a day, I mean, I ask myself the questions like, why? And we sort of realized that when we keep drilling down on those questions, why, we sort of get a different relationship that we're not currently capturing, right? I'll give an example. If, for instance, you are initializing your model and your model is working on some days, and I know that we used to have this problem with GANs where um no, we trained a lot of GANs. GANs was like it was like betting, you know. I remember I was working and then I was in Sunny and then we got a model. It's like, oh, let us quickly push this model because it is stable. We had trained like 50 different models and they weren't stable. But this is exactly how you see life. This is exactly how it is. But one of the things that you need to do at that point is ask the right questions. Why does it work now? Why doesn't it work then? Sometimes it might be as simple as your initialization strategy, and that tells you a lot of things about your model. Sometimes models work very well, but they're not, rugged. They're very sensitive, right? They are sensitive to initialization points. They have a very complex cost structure and loss function that navigating it is really, is really a pain. That is a story to tell about whatever you're building and whatever, you're trying to deploy. And I know that we always want it to work, but when it doesn't work in this regard, it tells a different story. And the two is that I'd handle it. Of course, I'll scream first, but then I will go back and ask the question, one, is there a problem with the model? Is it that as something that is making the model unstable? Are there strategies to make it a lot more stable? Or is it initialization? Is it about the model itself, or is it about the way that I'm going about solving the problems? And both of them have different approaches and different stories that they tell. And then that can actually help you to say, okay, fine. If I simply change this value, let's say, for instance, you have, your model isn't working as it should, and then you realize that at some point, oh, why isn't it working as it should? And then you realize that after a while, a lot of your neurons go to zero. Okay, fine. Maybe it's my value. My value is permitting zeros, and so I need to change that to a leaky value, right? That has told you a story, and maybe it takes you towards more stability. It might be like, oh, I need to just remove values entirely, but this is how I approach it. And then I also publish those.
Yeah, thank you so much. I will allow the rest of our panelists to chip on this direction, but I see in the Slido there's a lot of questions about negative results and failures. So I thought I'd quickly move to these questions, and it's like, but first we'll take one from the audience that says that Olumide mentioned about publishing research failures or just sharing them. My question or request would be, can he share his most recent research failure with us?
I'm muted. Yeah. So I was training a face recognition model 2 days ago. For some reason, this thing would not convert. Like, I don't know why. Like, so I know it was last week. So I spent all night trying to figure out why. And one of the things that I wanted, I was on a project where somebody wanted something that was much more biased to Black faces and also the environmental conditions for capturing those, because you know that when you do capture it, because of the texture of the skin and the intensity of the sun, what you get to have is high contrast environments that, you know, you need something that is robust to solve them. And so we created this data set, you know, had the model structure, state of the art. Just wasn't working. Like it just wasn't, it didn't work. And I did try for a week. And I mean, the entirety is not a failure, I would say, because last night I did have an idea as to why I was failing. And I know I tested it and it's to work a bit more. But that is it. But if you're looking for real failure where I had to publish that failure, that wasn't I couldn't publish it because it was rejected. The paper was rejected, but it was an end-to-end failure. Like, yeah, just telling us you failed. So there you go. So it was rejected, but it was something around voice. I used to be purely on sound, and we were trying to do something that I don't know if you know that Shazam has all the patents when it comes to MIR because they were first entrants and Apple bought them to acquire those patents. And so just from knowing the song when you whistle, without actually having to sing the lyrics of the song, it's a much bigger problem. You don't have the lyrics to drive the recognition. People don't know how to whistle as much as, or they don't know how to hum as much as they should. So you're looking at tonality problems. You're looking at pitch. You need to do massive amounts of time stretching and pitch shifting that, you know, and sometimes people start on one pitch and end up on another pitch. I didn't solve that problem and I published, but they rejected it. But then I went to a group of friends and then over dinner, I told them how I had failed.
Well, I'm pretty sure all researchers have this moment of failure. I know we're almost on the clock. I thought maybe Sahar could take this question on how should negative result be presented if like just briefly, in your opinion, how would you present such result if you ever had any?
Yes, I think it's actually last couple of weeks we've been thinking about this is that sometimes if you really want to know if method A is better than method B, this information would be it would be so hard to find because all published papers about method A, they would report only cases where method A works better. And then this is biased. You'll not get like really an objective answer because if you want to say that, well, it worked with my method, you will not show all the cases where actually other methods work better. So if you want to like know what is the limit of each method in general, if you want to have a meta comparison of the field, this information will be really hard to find. And sometimes actually, like I get an idea and then like I'm not convinced that no one else looked into it, because it sounds very basic or intuitive. And then now I don't know why no one actually is talking about it. Is it because it's failed when they tried it, all of them, or is it really stupid? No one thought that it would work, and it's because people sort of like they publish. I understand that you have like if you want to publish something, it's hard to publish it's all on negative results, but at least I think what we should do is if you finally reach some good results, it will be helpful for people later to know what you tried first and didn't work, in order to like avoid your mistakes, or like not mistakes, but avoid like repeating the same process that you have done and it took you some time actually to figure it out. So maybe it would actually be easier for people to replicate your experience, or maybe like learn from these lessons later. So I think it's sort
Or
of
maybe
like
you, it was good. So maybe you didn't even figure it out. You know, it's just really...
So I think we should sort of embrace negative results more. At least, like I'm not saying that well the whole paper should be about negative results, but at least to highlight them, not even only in the appendix, but highlight like the main summary of what you have done in the main paper, so that like interested readers will go to the appendix and read them. But yeah, and also like regarding actually the previous question, I don't think it's sort of like it would invalidate your results. Like for example, if your method works in like setting A, if it's like I don't know, in a white box or something, or like in a sort of the same data set, and you move to another harder setup, if your method's still not working better, then I believe this wouldn't invalidate the result, but it would be helpful for people to know how to take it from there, sort of.
Thanks a lot, Sahar. I would really like to take one question for Sewade and then a general question. I know that will take us above the clock. I hope we can stay a few more minutes. So Sewade, the question I would like you to answer is like, what's your take on omitting setting where the method proposed performed worse than the state of the art?
Okay. Okay, so I really want to, I do not know if I should answer as a reviewer or as, as a researcher, because so the thing is, it's really sometimes I would say you should really still include those results and tell us and tell this to us. It's just that it depends on how you approach it in your paper, all right, or how you tell the story. So, for example, you can present your results, then maybe in the appendix, as has been mentioned, you can then tell us, okay, these are extra experiments that show that for this different setting, the state of the art still performs better than your own proposed method. That's one way to do it. Because it's really about a story. You do not want to break your story, as I mentioned before. You really want to tell us that your method is really interesting. So you want to put this kind of thing as the later parts of your paper to really show us what does not work. So I really want to say it's still a nice thing to do.
But we should be cautious, right?
Yeah, so the thing is, yeah, you do not, as a reviewer, the thing is, I want to see where your method does not work too. Do you understand? It's nice to see it, and it's a question I also want to it's a question I have at the back of my mind. So that's what I'm trying to say, that it's nice to add it. It's now where to add it. It's like, you don't understand what I'm trying to say. So you want to bring in this kind of thing at the later parts, around the appendix, the ablations, where you know that these are more interesting things to look into. Yeah.
I don't know. I don't have a PhD, but maybe this is why I'm still a PhD student. But I would really like, I don't know, like omitting settings. It's really like it's not good for research. Like if you know that, like you've tried that method and then you see that it's not working, and then you just intentionally left it out just because it's not working, that feels like a research fraud. If you never tried it and you never figured out that it did not work, then it's a different question. But I've also talked to some researcher that's like they added some, and then when they published it, the reviewer was just like focusing on that tiny part that did not work. And that was like the basis of rejecting the paper. And in the next one, they just said, well, we're not going to put it here as like for you to pick on the thing to reject the paper. We will leave it somewhere in the appendix. Or so, like when you have the time, you can find it there. But like just some reviewers are just really lazy, you know. But it's a very difficult thing to navigate. I agree. There's no one answer fits it all. We have the field is getting very diverse, and reviewing is not as high quality as maybe it used to be. But I hope that we can come back to having good practices for research, which is like what I want to end with today. Like the last question that I would ask for today, and thank you so much for staying on until this time, is that what are some good research practices you believe should be more widely adopted? And I would like to start with Sahar.
So I think it's sort of like it's a two-way thing. It's just there because reviewers, as you said, is like they currently the reviewing system is just really messy and sort of noisy, and there are people that are rejecting some papers that shouldn't be rejected and other way around. So to cope with this, there are some authors may try to avoid reviewers just picking on some minor things on their paper. So sort of like, I feel like sometimes authors currently, they do not do thorough work sometimes in actually finding related work in the area. Because if you find something that's doing a little bit similar to what you've done, or maybe they are not fairly acknowledging the related work, even if they cite it, for example, because they don't want to say that's something that looked into the same problem that we did. And that's not good research, sort of. It's not a good research practice, because like you should be thorough and like transparent, and also like give people credit, because this is what you want to do. This is what you want to happen to your papers when someone else reads it. It's like just because the other researcher may be more famous, you shouldn't like go and cite only famous papers by famous researchers and then like sort of ignore other people that actually did that before. So I think it's hard to fix this if we don't fix the whole ecosystem sort of reviewing and others. But I feel like there is still a way in order to acknowledge, for example, previous work, acknowledge your limitations, but you would need to work a little bit harder in how to sell the story of, okay, people did that. I'm looking into slightly similar problem, but here is why you should still listen to what I'm saying, because, well, these are just sort of new problems, or these are just sort of better implementation, and this is new information that you would learn from this. But it's just balancing that. I don't think that the right way to do this is to sort of ignore the limitation completely, ignore the previous work completely. But I understand that it's hard to do without fixing the whole process.
Thank you so much, Sahar. Like I'm holding on to your point. Like as a good researcher, good research should, there is good and bad research. There are things that in the middle that we cannot capture right now because you want to have a PhD, and then you need to publish a top tier, and you need to figure out how to make that happen. But that should not exclude from you as a researcher knowing the good practices. You have to be thorough, do a thorough literature review. You have to be transparent, you have to make sure you're giving credits to past work, saying as it is. Like, a researcher is not a politician. You shouldn't be one. Like, you're like trying to find, you have a problem, you're trying to solve, you're proposing something. You should not be married to one solution. You're like, try so many things out. Like, that should be your the way you're thinking about it. So thank you, Sahar, for bringing that in as something we should be thinking about as we're embarking on research. Next, I would like to go with Sewade. Sewade, would you like to give some good research practices that you believe should be more widely adopted?
Yeah, so I thought about some, so I would want to just mention them now. So the first one I want to talk about is first, always be clear about your research settings and your hyperparameters. So I want to read your paper and know your research settings, hyperparameters, your learning rate, your total number of GPUs, things, because some of these tiny little details really affect results. So I really want to be able to see all those things in your paper. So like, make sure you include those kind of details. Also, write reproducible code. Like, I want to be able to see your code. I know it works. So please, when you do research, it's a pain in the ass if one picks up a code and you discover that you run it and it never works. You have to debug for 1 week and 2 weeks to make it work. It's like, wow, okay. The third one I want to talk about is consider the ethical aspect of your research also. So it's good to mention it in the paper. So while it's nice that you've created a model, also need to tell us how the model should be used and what it should not be used for. And if there are also some kind of guardrails that are necessary to be put in place for that model, it's also be nice to know about it. So the next one I want to talk about is while doing your own search, always also state the literature. So what I want to say is make sure you do a literature review. Tell us what is the state of the art in that field, on that particular experiment. Like, tell us, what has been done. Do not make claims that, my approach is the best, well, it's good to make that kind of a claim without considering state of the art. If other state of the art, or there are also other papers that have actually done something similar. So, because sometimes it affects publications, because a reviewer can tell you, hey, you mentioned you got this result, but did you consider this particular paper? And then it's like, well, I did not consider it, things like that. So make sure you really state where you're coming from, and you can easily do that by considering state of the art. And the last one I want to talk about is, while you make some particular choices in your experiment, it's always good to state the reasons in your paper. Do you understand? So, for example, if you make use of a particular argumentation method, we really want to know, why did you choose this method over other methods? So, because if I read your paper and I only see that you chose this method, but there's no reason, then it's a blind spot. Then, like, it's either I have to mail you to start asking you, excuse me, please, why did you go with this and not this? Well, I know it might be that the other argumentation methods did not work well, but at least it's still nice to know that that's your reason, Yeah, so that's all for me.
Okay.
Thank you.
Thank you so much, Sewade. And you also still like hammering on this point of being very thorough and very transparent, and give credits as Sahar. Like, those 3 points are always like is reoccurring, which I'm very glad that we all align in that regard. And just to wrap up, and I deeply apologize to our audience that we're like 10 minutes past. So, but just to wrap up, Olumide, please, can you please give some final words plus some advice on like what you believe should be widely adopted from a researcher point of view?
I think everyone has said a lot. And I think Sahar also mentioned that a lot of things that you want to adopt will mean breaking the entire industry, right? One of the things that I always tell myself, and I know it's a difficult thing, is that I am trying to communicate. I am not trying to impress. A lot of times as a researcher, I keep telling myself that, so it sinks in. And that influences how open I am with information, how liberal I am with information. I'm not trying to impress you in such a way that you cannot reproduce my code or you say, wow, the results look good, but yeah, I can't reproduce it. I'm trying to communicate. And what that means in the end is that I will tell you my failures. I would walk through the entire story. I will give you everything you need in order to tell your own story. I would make sure that I am very liberal with that information and I'm available. That's the one thing I keep telling myself, and maybe somebody might be able to use that today.
Thank you so much for that wonderful closing notes. And that resonates. Like, we're trying to communicate. I'm not trying to impress. I'm trying to do good work here. I mean, it can be hard sometimes, but it pays off. Like, good work always pays off. This is how I say in the long run of things. So thank you so much, Sewade, Olumide, Sahar, for being very generous with your time and for being here. And it's a pleasure to be your host today and to have you all join the community to communicate with them and to share your insights. So please, everyone, give a round of applause to our panelists and thank them, all our doctors and doctors in you. It's amazing. You have like PhD holders, almost PhD holders in the call. I'm so excited. Okay, yeah, anyway, so thank you so much, everyone. This is the end for today's session. Next week will be our last session for the research cohort, and I hope you've learned something the past 4 weeks. So, see you next week. This is AS at the Lagos second research cohort. Bye-bye.
Thank you so much. Bye.
Thanks, bye.
Thank you, bye.